Good morning everyone. Welcome again to the Chapter 1 Information Practices Part 2. In continuation with the previous video, in this second part we learn computer memory, units of memory, then we'll see types of memory. Along with it, we'll learn data capturing, storage and retrieval, data deletion and recovery. Let's start with the computer's memory. As we know, a memory is a capacity or capability to store data, or it can be defined as capacity or capability to store data. A computer needs a memory to store data and instruction for processing. Whenever we talk about a memory of the computer system, we usually talk about the main or the primary memory. The secondary memory is used to store the data and instruction and the result permanently for the future use. To continue with the same, let us see the units of memory. A computer system uses a binary numbers to store and process data. The binary digits 0 and 1 are the basic unit of the memory. Further, these bits are grouped together to form a words. A 4-bit word is called nibble. For example, 1001, 1010, 0010, etc. are the 4 bits or nibble. Similarly, 2-nibble word, that is 8-bit word, is called a byte. For example, 01000110 or 01111100, these all are the examples of 8-bit word called byte. Like any other standard unit, bytes are grouped together to make a bigger chunks of units of memory. Let's see this table. You can understand, after the byte there is kilobyte. So 1 kilobyte is equals to 1024 bytes. Similarly, 1 megabyte is equals to 1024 kilobyte. 1 gigabyte is equals to 1024 megabyte. 1 terabyte is equals to 1024 GB, that is gigabyte. After gigabyte there is a petabyte. So 1 petabyte is equals to 1024 terabyte. Then after petabyte there is exabyte. 1 exabyte is equals to 1024 petabyte. Then next is the zettabyte. 1 zettabyte is equals to, that is called ZB. 1 ZB or zettabyte is equals to 1024 exabyte. Then ottabyte, that is YB. 1 YB or 1 ottabyte is equals to 1024 zettabyte. So these are the units of memory. Now we will see types of memory. Human beings memorize many things over the lifetime and recall from the memory to make a decision or take some action. However, we cannot relay our memory completely. So we make a notes on important data and information using other mediums such as the notebook, manual, journals, documents, etc. Similarly, computer have 3 types of memories to store the data. These are, number 1 is primary memory, number 2 is secondary memory, and number 3 is cache memory. Let's see the primary memory. A primary memory categorized into 2. That is RAM and ROM. This RAM, that is random access memory, also categorized into 2, that is static RAM and next is dynamic RAM. When you talk about the ROM is of 3 types, that is PROM, second is the EEPROM, and number 3 is EEPROM. PROM is programmable read-only memory. EEPROM is erasable programmable read-only memory. EEPROM is electrically erasable programmable read-only memory. Now when we talk about the secondary memory, there are several examples of the secondary memory like hard disks, magnetic tape, CD, DVDs, Blu-ray discs, flash drive, etc. We will go through each of the categories of the memory one by one in detail. Let's start with the primary memory. When we talk about the primary memory, it is an essential component of the computer system. Programs and data loaded in the primary memory before processing. CPU interacts directly with the primary memory to perform read and write operation. You can see here this machine cycle. You can easily understand with the machine cycle how the CPU, as we have learned in the previous class, that the CPU consists of control unit and ALU. So you can see here in this figure that a memory, main memory is here. It is a part of computer memory, that is a primary memory. From the main memory, the control unit fetch the instruction and then its control unit decode the instruction into the commands, and these decoded commands are executed by ALU, and after the execution the ALU sends those executed commands back to the memory. This way one cycle goes on, that is called machine cycle. This primary memory is of two types. One is random access memory, that is RAM, and second is the read-only memory, that is ROM. Now let's see the RAM, that is random access memory. A RAM is a volatile, that is as long as the power is supplied to the computer, it retains the data in it. But as soon as the power supply is turned off, all the content of the RAM are wiped out. So it is called volatile memory. And this RAM is used to store the data temporarily while the computer is working. So whenever the computer is started or the software application is launched, the required program and the data are loaded into the RAM for processing. And RAM is usually referred to as a main memory, and it is faster than the secondary memory or the storage devices. RAM is again categorized into two types, that is SRAM, static random access memory, and second is the DRAM, that is dynamic random access memory. What is the difference between SRAM and DRAM? So their major differences are: the first, on the basis of the component, SRAM consists of the transistors, whereas DRAM consists of capacitors to store the data. If we talk about the refresh, in SRAM no refreshing is required, whereas in DRAM the contents of the capacitor need to be refreshed periodically. About the speed, SRAM is faster as compared to the DRAM. DRAM is slower as compared to the SRAM. Come to the cost. SRAM are more expensive as compared to the DRAM. In the density, SRAM are low density devices, whereas DRAM are high density devices. And we talk about the use. SRAM is used in a cache memory, that we will see further, and whereas a DRAM is used in main memories. So this is the main differences between SRAM and DRAM. Now let's see the second type of main memory of primary memory, that is ROM. A ROM is a non-volatile, that means its contents are not lost even when the power is turned off. So it is used as a small but faster permanent storage for the content which are rarely changed. For example, the starter program, that is a known as the boot loader, that load the operating system into the RAM is stored in a ROM. So ROM is again categorized into three types, that is PROM, second is the EEPROM, and third is the EEPROM. As I told you, PROM stands for Programmable Read-Only Memory. EEPROM is Erasable Programmable Read-Only Memory. EEPROM stands for Electrically Erasable Programmable Read-Only Memory. There are certain differences between the three, so we will see the differences between all these three, PROM, EEPROM and EEPROM. Let's understand the difference between these three with this table. PROM is read-only memory that can be modified only by the users, whereas EEPROM is a programmable ROM that can be erased and reused. EEPROM is user modifiable ROM that can be erased and reprogrammed repeatedly through a normal electrical voltage. That is why it is called electrically erasable programmable read-only memory. Now, PROM stands for Programmable Read-Only Memory that I told you previously. PROM was developed by Singh in 1956, whereas EEPROM was developed by Foreman in 1971. EEPROM was developed by George Perligos in 1978. PROM is a reprogrammable only once, whereas EEPROM can be reprogrammed using ultraviolet light, whereas EEPROM can be reprogrammed using electrical charge. So these are the major differences between PROM, EEPROM and EEPROM. Now next we'll see the cache memory. What is cache memory? Let's see the cache memory. A RAM is faster than a secondary memory, but not as fast as a computer processor. So because of the RAM, a CPU may have to slow down. To speed up the operations of the CPU, a very high speed memory is placed between the CPU and the primary memory known as the cache memory. We can see in this picture. To store the copies of the data from frequently accessed primary memory location, thus reducing the average time required to access the data from the primary memory. So when the CPU needs to access the memory, it first examines the cache. In case the required is met, it read from the cache, otherwise the primary memory is accessed. So this way you can see here the cache memory lies between the primary memory and the register, that is CPU. So this way data can be easily accessed from the cache memory and it makes the processing faster. Now the next we move to secondary memory. Secondary memory is a non-volatile and has large storage capacity than the primary memory. So primary memory has a limited storage capacity and is either volatile RAM or read-only, that is ROM. Thus a computer system need a auxiliary or secondary memory to permanently store the data and instruction for the future use. So we can say a secondary memory is a non-volatile and has larger storage capacity than the primary memory. And second is, it is slower and cheaper than the main memory, but it cannot access directly by the CPU. The contents of the secondary storage need to be first brought into the main memory for the CPU to access. You can see the example in the picture also, like hard disk drive, CD, DVD, Blu-ray discs, flash drive, memory card, external hard disk, or flash drive, SD card. These are the example of secondary memory. If you want to know in detail about all these secondary device components, so I have created one video that is in my YouTube channel with the name Computer Memories. So you can refer to that video. You will get in detail about the CD, DVDs, Blu-ray discs and the memory stick also. Now we move to the data capturing. To process the data, we need to first input or capture the data. This is followed by its storage in the file or database so that it can be used in the future. Whenever data is to be processed, it is first retrieved from the file or a database so that we can perform the further actions on it. So we will continue with the one by one. We will see first data capturing. Data capturing involves the process of gathering the data from different sources in a digital form. As we can see in this picture, there is a barcode reader that scans the bar. By scanning the bar, it collects the data. This is also known as a data capturing. So data may be captured using keyboard, barcode reader, remote sensors on the Earth orbiting satellites, etc. Even we are using the social media. So the comments or the posts over the multiple social media are also captured as data. Now we'll see the data storage. Data storage is a process of storing the captured data for the processing later. In large organization, a computer with a larger and the faster storage called the data servers are deployed to store the vast amount of data. Such dedicated computer helps in processing the data efficiently, and however the cost, that is including both hardware and software, of setting up a data server as well as its maintenance is very high, and especially for the small organization and the startups. So data storage plays an important role. So nowadays cloud storage is being used. That is a new technology to store the data. Now we'll see data retrieval. Data retrieval is another technique to fetch data from storage devices for its processing as per the user's requirement. As the database grows, the challenges involved in search and retrieval of the data in acceptable time also increase. So minimizing data access time is crucial for the faster data processing. Next we'll see data deletion and recovery. One of the biggest threats associated with digital data is its deletion. The storage devices can malfunction or crash down, resulting in the deletion of the stored data. User can accidentally erase data from storage devices, or hackers or a malware can delete the digital data intentionally. So deleting digitally stored data means changing the details of the data at bit level, which can be very time consuming. Therefore, when any data is simply deleted, its address entry is marked as free, and that much space is shown as empty to the user without actually deleting the data. In case our data gets deleted accidentally or corrupted, there arises a need to recover the data. Recovery of the data is possible only if the content or the memory space marked as deleted have not been overwritten by some other data. This is an important point. Sometimes accidentally somebody delete the data and asking whether that data can be recovered or not. Data can be recovered only if that space is not overwritten by some other data. So data recovery can be defined as the process of retrieving deleted, corrupted and lost data from the secondary storage devices. There are two security concerns associated with the data. The first one is its deletion by some authorized persons or software. These concerns can be avoided by limiting access to the computer system and using password for the user accounts and the files wherever possible. There is also an option of encrypting file to protect them from unwanted modification. And second is unwanted recovery of data by unauthorized users or software. Many times we discard our old, broken or malfunctioning storage devices without taking care to delete data. We assume that contents of deleted data are permanently removed. However, if these storage devices fall into the hand of mischief persons, they can easily recover data from such devices. This poses a threat to data confidentiality, and this concern can be mitigated by using proper tools to delete or share data before disposing of any old or faulty storage devices. So this is an important thing that must be kept in mind while throwing the old storage devices. So today we have covered the computer memory along with its types, then data capturing, storage, retrieval, along with data deletion and recovery. So in next class we will proceed with the next topic. So meet again in the next class. Till then, stay home, stay safe. Thank you.